Welcome one and all to the lesson on the angle difference formulas. And again, the angle sum and difference formulas are trig identities to make algebraic substitutions to simplify and verify trig identities, which will be useful for trig equations in the future, and specifically we're going to focus on sine and cosine. Now, if you watched the first part of my videos for this week, which was about the angle sum formulas, it's pretty much the same idea, just the formulas are different and the work is a little bit different. So again, just a review. So here are the Pythagorean. Here's the review on the Pythagorean theorem, the formula, and what the conditions are. Here's a review on the trig functions. We're using the wordings for opposite, adjacency, and hypotenuse. So please take note of that. And now let's get to the meat of it. So here is the formula for the difference identities for sine and cosine. So notice that there are some subtle differences between this compared to the sum identities or the additions. So please make sure you know the difference. Take note of what formula consists of, and make sure you use the correct one depending on the questions you need to deal with. So let's get to a primary example. So here's our primary example for the rest of this video. Again, there's a condition for positive acute angles for A and B. So again, it's pretty much telling us that all our values or ratios will be positive. So we are given cosine A is equal to 12 over 13, and this time we're given tangent B over 20 equal to 28 over 45. And this time we're asked to find the value of cosine A minus B. So first thing you always want to do is establish which formula we're using. So here's the formula: cosine A cosine B plus sine A times sine B. It's probably easier for this part to focus primarily on just the cosine A given to us, which was 12 over 13. And again, remember that's the same as adjacency over hypotenuse. So we can find sine A for that angle A. So drawing a triangle is probably our best bet to kind of get a picture of what we need to look for. So we know that the side 12 is adjacent to angle A, hypotenuse is 13. We want to know what the opposite is because that's what sine A cares about. So we use the Pythagorean formula, and if you solve this correctly to find the A, we have 5. So therefore, that gives us our missing piece, and now we can get the one we care about, which is sine A. And sine A is opposite over hypotenuse, which is 5 over 13. So far we have 2 out of the 4 fraction values or ratios we need for this specific formula. Now part 2 focuses on the tangent B that was given to us. So tangent B obviously is not part of this formula, but we know the ratio, 28 over 45, which is the same as opposite over adjacency for a right triangle, which means we can use this to find both sine B and cosine B. And thankfully the work is not much different from the previous slide. What we do is we draw another right triangle like we normally do, but this time we don't have the hypotenuse. We have the opposite side, which is 28, and we have the adjacent side of 45. But both sine B and cosine B depends on the hypotenuse being the denominator of a fraction. So we need to find the hypotenuse. In order to find the hypotenuse, use the Pythagorean formula again, but this time we need to find C. Follow the steps correctly, and you see that for this problem we have C is equal to 53. So therefore, we have our hypotenuse for this triangle. And just because I noticed it in time, I will put a tiny right triangle symbol there. But now that our triangle is complete, we can now find both sine B and cosine B. So remember, sine B is opposite over hypotenuse, so that gives us 28 over 53. And cosine B is equal to adjacent over opposite. Oops, wrote the wrong one. I should fix that right now. So it's adjacent over the hypotenuse, not the opposite. That is a different trig function, which we don't really care about right now. But the numbers are the same, 45 over 53. Therefore, we have all our pieces. So this is the last part to this problem. Again, here's our formula. First thing is establish which ratio or which fraction values go with the correct trig function with the angle. So cosine A is 12 over 13, cosine B is 45 over 53, and so on and so forth. Then, just like the angle sum formula example I did in the previous video, you have these two fractions being multiplied with each other to give us 540 over 689, and 5 over 13 times 28 over 53 gives us 140 over 689. Thankfully, again, both fractions have the same denominator, which allows us to add these two fractions together, and all we have to do is just add the numerators together. So 540 plus 140 gives us 680 over the denominator 689. That gives us our final answer because it is not reducible at this point. So that is the end to this lesson. Again, if you get stuck, make sure to watch the Delta Math video too, which also does a more thorough explanation of these types of problems.